Hola chamas y chamos, welcome back to Alvaro Dev Labs. It has been a while since the last video. The reason is that I recently moved with my girlfriend to a new apartment. We buy a flat nearby Barcelona, and we have been really busy like moving out, painting, repairing stuff. I managed to do this small like a studio right now, but it's not finished. And just beside me, there is a ton of boxes and stuff that we need to put in the apartment. So that's the reason I had been away from creating content, but I wanted to create a video today. During this time, I also was doing a course by Bruno Simon. It's a ThreeJS journey when he explains how to use ThreeJS, how to model things in Blender and export them into your scene, how to create immersive web experience with 3D. I totally recommend this course. It was amazing for me. I always thought that 3D was out of my reach, out of my knowledge, and it's actually not true. So you can learn 3D and do amazing stuff in the web. During the course, Bruno teaches using Webpack, but since I'm really into modern front-end technologies like Vite, I thought why not creating a 3GS application using Vite and using functions as type of class. The results are amazing, and that's why I'm creating this video. For this tutorial, I'm gonna assume you have a basic knowledge of 3D and also 3GS, because I'm not gonna dig too deep into it. Although there are a lot of real good content on YouTube how to use 3GS, I'm probably gonna create more basic tutorials about it. Let me know in the comments if it's something that you would like to see. But for now, I'm gonna focus how to create 3GS with Vite. So let's jump into it. So 3GS. I'm in the webpage of 3GS where you can find a lot of cool examples of people using it. Here, for example, is the course by Bruno Simon, and I think this is a portfolio. You also have a lot of cool examples, one for Billie Eilish, Medal of Honor, and this one is one of the ones that I love the most. It's using like custom shaders, and it's just amazing how immersive it is. So this is the kind of stuff that you can build with 3GS. And the other thing that I wanted to show is the front-end tool that we're going to use. So as I mentioned before, a lot of the examples that I see on the web are using Webpack. So I thought about using Vite for it because it's the next generation of front-end tooling and it's really fast. So let's see how we can make it work together. Here we are going to go as always to our scaffolding or Vite project. I'm gonna use PNP command, and actually I'm going to create a vanilla TS. So let's open the terminal. I'm gonna open my projects folder and probably GitHub folder, and here I'm gonna use pnpm create Vite, and let's just create something like modern 3GS app. Since we didn't put what kind of project we had, we're gonna be prompted as selecting the framework. I'm going to use vanilla and TypeScript, and let's just code our new project. So modern 3GS. These commands just open a VS Code directly from the terminal. So let's just open here a little bit bigger so you can check it correctly on the video. And it comes with the bare basics like a source folder and just a package JSON. So with this, we can start creating our scaffolding for 3GS applications. Next thing will be to install the dependencies. I'm going to open a terminal here in the VS Code and just use pnpm install. And that should install by the moment of this tutorial Vite version 2.8.6 and TypeScript version 4.6.2. Let's go to the webpage of 3GS, and here in documentation you have the basic usage. You can download the code or you can install it as an npm package, which is the way that we're going to use. So here you have the command. We're gonna use normal pnpm. So pnpm install tree. Now let's check that everything went well, and let's just pnpm run dev, and this should open here on the local host. So if I click here, since I'm incognito, I need to copy and paste it here. So showing hello Vite, so it's working. And now let's see if we install correctly, or let's remove this part here. We will not need it. And we can have some styles, but I don't think we're gonna need it anyway. So on top of this, let's just import as tree. So this is like import everything as tree from ThreeJS. And let's just console log it to see that it's actually working. So tree here. Let's see the inspect mode, console. So you will see here a model with everything that the library comes with, which is a lot. You can scroll and scroll and scroll, and you will see everything that is between the tree module. I took some minutes to organize better the layout, so you can see the code on the left and the browser or the result on the right. And we're gonna work on the main TS, which is our basic TypeScript file that is going to be imported here in the index.html. So you can see right away that it cannot find the declaration file for module 3. And that's because we haven't installed and configured our types to use 3. By default, I think the library doesn't come with TypeScript definitions, so we need to install them separately. For that, we are going to do pnpm install types 3. I think you save it as a development. Yeah, dev dependencies, and you will see that right away is it removes the warning. You can also here in the TS config for terms like autocompletion and stuff. Let's use types and let's add few of them. So one will be node, yes. I need to do it with double quotes for some reason. We are going to add also Vite client. Let me see if this is the correct one actually. I have another app just here. So yeah, Vite client, and the other one is 3. We're gonna install another one in a moment, but for now we're okay. So let's go to the main TS, let's remove the console, and let's start creating our scene. So I created a really basic scene. As I explained before, I'm not gonna go too deep into it on how to create it. I'm gonna assume you have a basic knowledge of ThreeJS. But I put everything in the main TS, and I'm importing everything as a tree, okay? And I created the scene. I created a camera, a perspective camera, which is the more likely to your eye, with a vertical field of view of 45, which is the normal. If you want to have like a more, how do you say, like GoPro kind of look, and you can increase it. I added some lights, so an ambient light for the whole scene, and also a directional light that is going towards here. I added to the scene with these two. I put the position of the camera to these coordinates, so you can see it a little bit more isometric. Here, the important part is that in the index HTML, I created a canvas with the idea of experience where everything is going to be rendered. And I just create a variable here with the canvas, the HTML element with the types, and just query a document with the idea of experience. And then I pass it to the 3GS WebGL renderer, which is an object that allows you to pass the canvas and that make that connection between the JavaScript and the DOM. I tweak it a little bit so it's a little bit more realistic in terms of shadow and lighting. And I also enable the shadows here. This is a more basic stuff, like whenever we resize the screen here, it adapts the camera and also the renderer with the proper width and height. At the beginning here, there is some size that corresponds to the window inner width and the window inner height. Whenever we resize the screen, it's gonna be updated automatically. Also, I set the pixel radio. The pixel radio is because some screens has more pixel radio than others. And to clamp it, we're using a matmin here. So the maximum is like 2, okay? What else should I comment? Yeah, I created a sphere with a tuned material, really basic with my brand colors. And I used the cast shadow, so it can cast shadow into this plane that I created here. What else? The usual stuff. I also added the orbit control so you can scroll and move around the scene correctly, okay? And the basic loop. As you may know, you want it to be rendered at 60 frames per second at least. So that's why we are using request animation frame. So we iterate this loop and just render the scene. Using one main TS file for having audio code is okay if it's a basic scene like this one, but it's not gonna be the case always. You're gonna add more objects into the scene, more lights, more twigs, more code. And this is gonna end up being a huge file, which is not gonna be that performant, and also it's not gonna be easy to maintain. Okay, so for the sake of having a proper structure in your application, I'm going to show you how to reorganize this in several files, where one is going to contain the renderer, another one is going to contain the camera, and so on, and we can clean up a little bit. Also, it's going to allow us to reduce the amount of spaghetti code. What does spaghetti code mean? It's basically having everything in one file and just referencing things in JavaScript in the same file and having to scroll. So okay, let's do that. Here I'm going to create a folder with the core stuff that we have, right? And inside of it, I'm going to create something that's called renderer.ts. Okay. In the renderer.ts, let's try to pass everything that we have here for the render, right? So we have, where is it? We have size. So this one we are using it. So let's add it here. So we are using this part until probably here. No, this one is also part of the render. So until here. Let's cut it and paste it in here, right? Let's save, and we will see then right away we need the camera. Let's create another one for the camera. So let's use camera here, .ts, and we're gonna pass everything that we had here for the camera. So the camera also is from here, right? So let's put it here, and we're not importing ThreeJS, so let's do it as we do it in the main one. Also, something that could be interesting here, instead of importing the whole thing, is actually importing the things that you need in that specific file. So in this file, we need the perspective camera, so we imported only that, okay? That is gonna be useful afterwards. So export the full camera, cool. So in the renderer, we could import it, right? We also could import these sizes here. Does it make sense? I don't know. Let's see, export const here. Sizes, and we're going to import the camera, right? And the sizes. Okay, we're going to from camera. Cool. Of course, we need to remove this one. Here we can do also the same thing. So let's remove both of them. And I guess we're gonna have the out importer here, which is nice. So add all missing imports. Okay, import WebGL renderer and PCF shadow map from tree. Perfect. Let's see that. Let's save it, and yeah, let's try to import and then see what happens. Probably gonna break, but we're using the camera here. I don't know. So this is in add camera. We can add it here. I don't know why it was so down below, but we can use it here. And we are gonna face another problem, like where is the scene? So here is where you can like decide where you want to have the code, right? My approach is that I do have this file for the camera and I import that into the main TS that is the one holding the scene. And then here I add it. So basically I do this. I import the camera here by using camera from camera. It's gonna be in core, so it's core camera, cool. And then I add it here at the end, probably. Another thing that we need to do is update the render. So updating the render is a function that is now inside of here. Let me save this one. It's now inside of render. So it will be good if we export it. And also, we probably want to export also the render if we want to use it in the main TS. So just on top of the camera, let's import the render. Also, it's important to have that. Yeah, now I remember why we want the render. Because we use it on the loop. Okay, so it's not render, it's in core render. And this one, we are using it right here when we render the scene. And we also use the camera, so that's important that we have both of them here. What else? Update render, okay, perfect. And I already saved and it continues working, so it works as expected. Something else that we can have in the render TS is the orbit controls. So the orbit controls, you see, now that I removed them, the scenes looks kind of weird because the hot model replacement replaced it and removed the orbit controls. So that's why. We're gonna pass this import here. I don't know why ThreeJS doesn't add directly orbit control to the bundle. You need to access examples GSM controls orbit control. Maybe for performance reasons, I don't know, or to reduce the overall bundle of ThreeJS. Not everyone uses the orbit controls, but I think they're pretty useful, especially when you're developing, because it allows you to move your scene and see your object and see if the shadow is being casted correctly and those kind of things. So now we have a pretty decent size in terms of the main TS. We could improve this even further if we remove the camera here from the render. Why? Because I like when I'm programming, I like that the files have a single like responsibility, right? And we are adding code in the render, even if we are using the same thing. Whenever we are resizing the screen, we are both updating the render and the camera, we are updating the aspect ratio and the projection matrix. We could add this exactly, the Windows add event listener resize into the camera, so we will not need to import it. We will only need to import it into the orbit controls, which also we could have in a separate file because we could configure it. So maybe let's do that, right? First thing, let's go to the camera. Here, window, add event listener. Oh, pretty clever. Okay, I'm gonna add it empty. And let's copy copy and paste the code here directly. Yeah, here, and we also want to probably update this the same way that is being done here, so we have the same. Okay, cool. Yeah, maybe you're repeating the event listener, but at least you have all the code that updates the camera in the camera file. Okay. What else can we do? We could have the orbit control, so maybe I don't know, it depends. You can leave it here and just import the camera here. It doesn't matter that much, but we could create also controls here. Let's orbit controls. Orbit controls.ts, and we just copy and paste here this. Of course, we need to import the render. As I said before, this is really arbitrary. It's based on my my best practices, but you can do it as you better program. Like, let's import here the camera from camera and import probably the render from render. And we just need in the main TS to import this bad boy here. So orbit control, yeah, just import the core orbit controls. See if it actually works. Yeah, it works fine. It's a little bit more elegant this way. So from here on, we could do way more enhancements to the code. It depends on the team you're working on, the best practices you follow. I have seen code that, for example, this WebGL part is only one small piece of the whole web page that you're doing. Maybe you are creating a hero component where you have this scene to do a storytelling, and then you have the rest of your application. So instead of having it in main TS, you probably want to create a file called experience TS where you hold this kind of information. Some people use classes, for example, in the course, Bruno used classes for the experience. I normally use function, factory functions, or if I need some kind of inheritance or something like constructor. Sometimes I use singletons for them. It depends what I want to achieve. You can also take the lights, for example, in another file. So we could add it in lights file and just put all the lights there, or maybe you want to have a more testable code, so you will create a function that retrieves you instances of the classes. It's up to you, because this is really manual. If you see, like when we create the directional light, ThreeJS use classes underneath. Okay, so it's a class called directional light that extends light, and it makes sense for ThreeJS to use classes because they take advantage of the whole inheritance thing. I'm not a big fan of JavaScript classes because they're not really classes and or languages, and they're just a fancy name for prototypes, constructors. But that's okay. You can decide how you want to implement it. I normally what I do is I create some functions that retrieve you instances of lights, and you then can pass the typical first two parameters, which are the ones that you use in the constructor, the color and intensity, for example, in this one. And then I pass this as an object, and then I assign it to the directional light, so I don't have this amount of code here. And I can also reuse it instead of copy and paste it if I want a second line. That's completely up to you. Something that I do want to show you how to do is how to add a graphical user interface to debug your scene, because as you might figure out already, we are dealing with a canvas, and canvas are really tough to debug. You basically need to put things in the code to be able to see things. So how we can, for example, I don't know, move the ball to see where it fits better, right? So I really like to use something that is called tweakpane. There are other options, but this one is really well designed. And I'm sorry, I'm really a fan of nice interfaces, like nice UX in this kind of stuff. And this one really nailed it. How can I install it? Let's go to get it started. And you can use the CDN version. As always, we are going to use the npm package. I'm going to create another terminal here to not stop the application, and I'm just going to use npm install, and we are going to install tweakpane, and we are going to install also, because we are using TypeScript, we are going to install the type definition. So tweak, so I put it wrong here, tweakpane, okay, yeah, tweakpane core. Okay, let's install it. Okay, and here we are going to create another one called graphical user interface. To use it, we come here and we import pane from, just remove the sidebar, from tweakpane. Okay, and we are going to export const object called this one, which is new pane. Okay, we don't pass any parameters, and we go to our main, and let's import it here just below the camera. So import from, my cat is snoring super loud. I don't know if you hear them. So we import, we have it in core, yeah, okay. How we can tweak things. So let's see where we have the sphere. We have the sphere here, and after this, let's use GUI and add input, and we pass the object that we want to modify, which is going to be the sphere. In this case, the position is X, Y, and Z. So we cannot do something like position here and then access the three of them at the same time and add a controller for them, but we can do it individually, okay? So position here and then X, and then we need to pass the parameters here. So basically this is the object, this is the property that you want to be able to control, and then the options of controlling. So in this case, we want to have a minimum of 10, a maximum 10, and a step of 0.1. Let's save. You see now that we have a control panel here, and it has a little slider that we can use to modify the X value of our object here. And you see this working right away because we are modifying the X value. We could do the same for the G and the C. So G and V. And let's see it right now. So the G is gonna be like this, okay? And this is gonna be the C. That's pretty cool. We can also add like booleans. So in the material, we will have something like wireframe equal true. So let's see. Okay, let's see if we can tweak this one with control. So here, add input, and we say sphere material wireframe. Yeah. Okay, so we want to modify wireframe, and let's put it like this. So this is gonna be a checkbox here, and you can check. Depends if you're doing a scene and you really want to see the meshes around it. And also it's cool that the shadow is from the wireframe itself. You can do it like this. What happens if you have a lot of inputs, right? Because right now we are touching the sphere, but maybe we have another objects and we want, to identify, okay, I'm using the position of this one and so on. You can create folders. So the way of creating folders is really simple. You do const, a sphere folder of sphere controls. And It's gonna be add folder sphere, and instead of adding the inputs directly to the user interface, we're gonna use it on the sphere create. We did something wrong because this is actually not correct. We need to pass a name here, an object. And it's not name, it's title probably. Yeah. So here you have your folder with the position of your X position, Y and Z. You could also say here, because maybe you are also rotating the, you are controlling the rotation of the object and you add an input for that, then you can label this one. So this is gonna be position X, like this. Okay, you can change the label. Another thing that is really important when you're working with ThreeJS and 3D in general is to watch out for the performance. And how we can do that, we need something to tell us if the frames are not dropping. The frames per second, you remember we need to do each render in 60 frames per second. So how we ensure that we're actually having a good performance? tweakpane has an amazing plugin that comes with the plugin essentials. So I don't remember if it's something that you need to install. So I'm going to install it just to make sure. Okay, it's add tweakpane plugin essentials. And let's go to the when we define the GUI part, and we're going to import them all as essential plugins, and we're going to register it. So register plugin, essential plugins. And we are going to create a FPS graph. So it's add graph, no, it's add blade here. These are the blades. I actually don't know what it means, a blade, okay? Maybe it's a new part, I don't know, like a section of or a line here. I really don't know what is a blade, but the way of doing it is like this. And instead of here, you're gonna pass an object that is gonna be view FPS graph. I'm gonna put it like this, and then the label, let's put FPS, right? Okay, we now see there is something here in the tweakpane, but it's not doing anything. It's not showing us the frames per second because we need to tell the application to use the FPS graph. So we are going to copy this one here, and we are going to import it into our main app. So import, actually, we import it here. So let me make sure that we are exporting it. Yes, we're exporting it. And in our render loop, just before the render, we're going to do FPS graph begin. So it's going to tell you that it doesn't exist on Typelate API, but it's actually, I think we need to install or create some types for this because it will work, just as it doesn't show you this part. And before the render, we're going to do FPS graph n. And if we save, now we see that it's taking the frames per second, and it's all in 60 frames per second. And even if I move the wall, is still in 60 frames per second. That means that we're doing our code correctly. It could drop a little bit sometimes, especially I think if you change here and it has to redraw again and so on. Maybe it drops a little bit, but this is an excellent tool for you to check on the performance of your 3GS. At the beginning of the video, I recommended you right away to use Vite instead of Webpack, but I never really explained it why it's better to use Vite. Let's do a speed comparison on the run dev, and on the left side I have the tutorial that we have been working today with Typescript and Vite, and on the right side I have exactly the same basic scene but using Webpack. Also notice that this one is using JavaScript, so in theory should be faster because it doesn't have to transpile the TypeScript. So I'm going to quickly, in both terminals, remember right is Webpack, left is Vite. I'm gonna run on the try to run on the exact time the run dev, and let's see what happens. So I enter here, and you kind of saw it here that Vite loaded faster than the Webpack. Same, it's exactly the same scene, but this one took longer to appear. Also, if we check in the consoles, maybe we can see actually how many milliseconds. But the Webpack one doesn't actually say it. But the Vite one was about half a second. Okay. As I said before, for example, if we change something here, let's change the ambient light color, right? Let's put something like red. And here, red as well. So I'm gonna save this one, and right away, this one was compiled. Of course, this is a small application, so maybe you don't notice that, but believe me, Vite is way better in terms of the speed and performance. Also, another thing that I wanted to show you is that the code, essentially, so the configuration. For the bundler here, let's just take the common one. This is a standard way of creating the configuration for Webpack. And let's see the amount of code that we need to do this one versus the code that we need for Vite. So for Vite, I have only this configuration, which has the server to open and host it into the network so I can access it. And to configure the Webpack one, we need to create all of this stuff. And also we need to set up like different loaders and plugins in order to take the static web folder here. We also have can have a static web folder here that works right away for your assets. The more you go down, you need an HTML loader, Babel loader, if you're using ES6 or Browse, CSS loader, image loader, and if you're using TypeScript, you probably need also a TypeScript loader. With Vite, you don't need anything of that. You basically, if you want to use Sass, maybe you need to install Sass right away, but for the rest, you don't need this many code to put your application running, right? If you just want to use this code right away and start doing things with ThreeJS, I have a repository template in GitHub that you can download, or basically you can install it with this command here, nps digit and the name of the repository. You can create your repos directly from this template, and it will give you all the boilerplate that you need to start creating stuff in ThreeJS. I'm not updated it quite often. Here are the features. It's powered by Vite, Git controls by tweakpane, TypeScript, no classes, just functions. I'm going to probably add more features. One of the features I'm working right now is to add shaders with GLSL. I'm going to create another video about it. But yeah, let me know if you like it, and the link is right away in the description, so you can start using it today. Give it a start. And that's how you use ThreeJS with Vite and modern frontend tooling. Oh my god, I really have a blast doing this video. I hope you too, and if you like it, please subscribe and drop a like. I'll be doing more videos about 3D because I'm really passionate about it right now. Maybe how to mix it with Vue or any other framework. Let me know in the comments what you all like to see. Happy 3D!